There we go. All right, guys. So, quick review. We saw what is the definition of a conjugate. We use that definition of conjugate to know how to divide complex numbers, right? Here's some process of how to divide complex numbers, right? Two examples, then we have another example and a third example. Dividing complex numbers, absolutely simple. Today, we're going to expand this a little bit further. We're going to expand the use of complex numbers. We're going to expand them by solving quadratic equations. So you guys remember this, right? You guys remember this from the last term. We saw how to solve this equation, right? X squared equals 4. The solution is, as we know, we just isolate the x by doing the square root, but the square root can be positive or negative, right? We know this. So the square root of 4 is 2, meaning the solution is positive 2 or negative 2. Again, since this is a quadratic equation, we have two solutions, possibly two solutions. One positive and the other one negative. Beautiful. The equation has two solutions, negative 2 and positive 2. Beautiful. But what if the number is negative? Look at this. X squared equals negative 9. Another example. You would do the exact same process, right? Isolate the x by doing the square root on the other side. That square root is both positive and negative, right? But now we have to think ourselves, what is the square root of negative 9? Please do not say negative 3. No. So far, we know that the square root of a negative number cannot happen. That is a number that we don't know. But with the addition of complex numbers, this can be done, right? This can be done. Solution. We know that the square root of a negative number is the square root of the same number, positive, and then an I. This I will be the square root of negative 1. So we can take out the negative out of the root, right? And by doing this, now we can find the root of 9. The root of 9 will be 3. So we have positive and negative 3i. The equation has two solutions, positive and negative 3i. Just like Sara Jimenez in the chat said. Beautiful, Sara. Keep it up. All right, these are complex equations. These are the same quadratic equations, but now the results inside of the root could be negative. Try to do another one then. Solve the equation x squared minus 4x plus 8 equals 0. This equation. But we are going to solve it in the complex number system. What that means is, if we happen to have a negative root, we just do the I trick. Here it comes. Solution. Since this is a quadratic equation, we can use the quadratic formula. Hopefully you guys remember this, right? We saw this the last term. This b is the coefficient of x. This a is the coefficient of x squared. And the letter c is going to be the constant term. From here, simply find the values. We have our a will be 1. Look, the coefficient of x squared will be just 1. The coefficient of b, the coefficient of x, the value of b, the coefficient of x will be negative 4. And the value c, the constant number, so 8. All we have to do now is replace these values into the equation. We have x is going to be negative b, so negative, negative, negative 4, negative, negative. Did you see? Double negative. Negative for the equation and then the negative for the number. Plus or minus the square root of 16 because it is b squared. b is negative 4, so negative 4 squared, 16. Minus 4 times ac, 4 times ac. A is 1, c is 8. So 4 times 1 times 8. Beautiful. Over 2 times a, so 2 times 1. All we have to do now is do the algebra. If we multiply these, we're going to have 16 minus 32, which is negative 16. 2 times 1 is 2. And negative, negative 4, double negative means positive 4. What do we do now? All right, so we have a square root of a number, but that number is negative. What can we do now? It is absolutely simple. All we have to do is remember that we are in the complex number system, So we know that this root can be done if we take out the negative and create an I, the imaginary unit, the I. Solution: 4 plus or minus, and the square root of negative 16 will be 4 times I, 4I. Look at that. Over 2. From here, we know we have two solutions. By the way, we can simplify the 2 and the 4, right? 4 and 2 is, if we simplify this, 4 divided by 2 is 2, and 4 divided by 2 is 2 as well. So from here, we know we have two solutions. One is going to be with the positive sign, and the other one is going to be with the negative sign. So we have 2 plus 2i and 2 minus 2i. 2 minus 2i. The equation has two solutions. Now, every single one of these quadratic equations is going to have two solutions. Every single one of these. Every single one of them. But there is something interesting about the results, about the solutions. Guys, what is the characteristic of these two numbers? In the chat, please, let's see who gets it first. The solutions, this is one solution and this is another solution. Do you notice something? How do you call those two numbers?
Complex numbers?
Almost. Yes, they are complex numbers because that is the solution, right? Complex number system. But no, yes, Sara Jimenez. They are the conjugate of each other. 2 minus 2i is the conjugate of 2 plus 2i. And 2 plus 2i is the conjugate of 2 minus 2i. This is the conjugate of these, and this is the conjugate of these. They are the conjugate of each other. And that will always, always happen in the complex number system. How beautiful is this? How beautiful is this? All right, guys, we have some exercises here. We are going to do this eventually, all right? We're going to do this today. But before we do this, I'm going to introduce you to something new. I'm going to introduce you to something new. If you're taking notes, make sure you leave a space to do the exercises, all right? We're going to do all of these exercises today. But also today, we're going to learn something new about mathematics, polar coordinates. Now, don't take a lot of, don't put a lot of intense interest in this name, right? Forget about this name for now. We're going to jump into something a little bit more easier. Guys, if you're taking notes, go ahead and write this name, radians. These, what are these? What are the radians? All right. Radians are a measure of degrees. So for example, do you know how in mathematics things can be measured in centimeters, right? But maybe things can also be measured in meters or in kilometers, right? All of those, the ones that I just said, are different measurements for a same measure, right? Radians is exactly the same. So far, we know how to measure angles using degrees. So 45 degrees, 90 degrees, 120 degrees, 360 degrees, which is going around the whole circle, right? That is one measurement, degrees. But now we're going to learn there is another measurement, radians. This measurement is also a way of measuring angles. We can measure angles using degrees and we can measure angles using radians. This is why your calculator can be switched between radians and degrees. All right? Now, how do you use degrees? Here, Use the following formulas to convert radians to degrees or degrees to radians. Here are the two little formulas. If you like to take pictures, go ahead and take a picture right now or on screenshot. We are going to use these formulas a lot. Let me explain these formulas. All right, so let's say you want to change from radians to degrees. So you're going to use the first formula, right? The amount on degrees will be equal to radians times 180 divided by pi. So if I give you 3 radians, you put here, instead of the red, you put 3. And then use the little formula, and voila, you have your degrees. But how about the opposite? Do you want to change from degrees to radians? You use the second equation, right? In here, in degrees, you're going to write down the amount of degrees. If I said 45 degrees, so you're going to write here 45 degrees. 45 times pi divided by 180, and that will give you the amount in radians. Don't worry about this. We're going to do some examples right now. All right, so what I want you to do, guys, please go ahead and take out your calculator and do these examples with me. Do you have your calculators now? In the chat, please. Yes or no? Okay. Some people have the calculators. Some people. If you don't, guys, if you don't have your calculator with you, you're going to have to use the calculator of the computer or the one of the cell phone. You are going to have to use calculator for these guys, all right? So, Salome, please. All right, for the people who said yes, thank you, guys. For the people who said no, go ahead and find one. And for the people who didn't answer, what's going on? Are you not paying attention? What's going on? All right, let's continue. From here, let's begin with the first one, A, 60 degrees. So we want to change from degrees to radians. What formula are we going to use? Again, from degrees to radians. Are we going to use the first or the second? First or second? Which one, guys? In the chat, please. Beautiful, guys. Beautiful, guys. Excellent. You are correct. We are going to use the second one. If we want to go from degrees to radians, we're going to use the second equation. However, I'm going to write it right here in the corner just so that we don't forget about the equation. Here it is. It's the second one. Look. Radians is degrees, whatever. Radians is degrees, whatever, right? So all we have to do now is take out our perfectly beautiful calculator and write 60 instead of degrees. If we do so, we're going to have 60 times pi over 180. Now, the word radian is because whatever we have as a result will have this measurement, radians. You can forget about this word if you want to. Eventually, you're going to have to write it down, just like in mathematics. Whenever you use centimeters or meters or whatever, you have to use the units, right? At the end of this answer, at the end of the equation, sorry, in the answer, you're going to have to write the centimeters or kilometers or whatever, right? This is the exactly same thing. At the end, we are going to have to write the units, which is radians. So if we put this in the calculator, we are going to have pi divided by 3, which rounded to some decimal is going to be 1.047. The people who did it in this in the chat are Parrado, Sophie Gonzalez, Carlos, and Luna. Beautiful, guys, beautiful. Although only Lunita remembered about the units. Guys, don't forget about the radians, right? There you go. Sarah Galvis also, you also got it correct. 1.04 rad. Beautiful. Now, if you are lazy like me, because I am really lazy, I don't like to write radians. I like to write rad. R-A-D. If you do this, rad, that is correct. That is a perfectly good unit. Juan Sebastián Parrado says, Profe, que Ethan está enfermo. All right. Thank you, Parrado. Thank you. I appreciate it. Please tell Ethan to get better soon. Thank you. All right, let's go for the second one, guys. 150 degrees, change it into radians. If we put this in the calculator, let's do this fast. We can simplify, right? If you don't have access to a calculator, this is a perfectly good answer. Pi divided by 3. This is a perfectly good answer. Pi divided by 3. But if we have a calculator, well, we can put this in the calculator and round the number. It won't be equal. Look, this is equal, but this is not equal, right? This is round. So the answer will be rounded. But if you leave it like this, will be perfect. If we round this answer, we will have 2.618 radians. Beautiful, guys. Let's continue. We can also do this with negative degrees. If we put this in the calculator also, if we have negative degrees, makes reason to have negative radians. And this is negative 0.785 radians. Beautiful, beautiful stuff. Beautiful. Absolutely simple. Again, for the people who are having difficulties, change the number of degrees instead of the word degrees. Negative 45 times, look, 5 over 100. So times 5 over 100. Put this in the calculator, press the enter, and you will have this decimal. That is it. Let's jump to the next one, 90 degrees. Let's see who gets it first. We have 1.571 radians. And last but not least, 107 degrees. If we put it in the formula and then in the calculator, we round to 1.868 radians. Beautiful, guys. Perfect stuff. All right. Congratulations. Now, please, in the chat, go ahead and write. Did you find this difficult or easy? All right. 10 people are saying easy, teacher. Man, very easy. Even Richie says, all right, dude, pretty good. Easy, easy, easy. Thank you, guys. All right. I find this to be easy as well. But there are a couple of things you need to remind about radians. And for this, I do need you to write these down because I didn't put them in the presentation. Why? Honestly, I forgot. So please write them down somewhere. Right? These are two important notes about radians. All right? Number one, let's discuss the units, the rad. All right? The rad. Rad is the units for radians. Also, you can write the whole word, radians. That is correct. What is the units for degrees? The units for degrees is this one, the little circle on top of the number. That is the unit, all right? But what if somebody is being a bad student or a bad book, because books can have mistakes. So what if someone doesn't have units? What if instead of 60 degrees or 60 radians, that can happen. What if you just find 60 alone without the units? Then how do we know which one this is? Is this 60 degrees or units? Remember, we are talking about just the 60 alone. Let me change to the board for this. Let me change to the board for this. All right, so the example, if we find this, theta equals 60, but the 60 does not have any degrees or radians. In other words, it doesn't have any units. Like this, theta equals 60, but without the units. If that happens, how do we know what are the units of these? There is an easy trick. If there are no units, that means the number is in radians. All right, guys? If we do not have units, the number is in radians. All right? In this case, theta, since we don't have the little circle or the word rad, we don't have units, that means the number is in radians. All right, guys? Why am I telling you this? Because in some cases, some books will happen to have these, right? Maybe even Alex. So we need to understand what the book or what Alex is telling us. Again, no units means the number is in radians. Beautiful, guys. Excellent. Now, another thing. I told you they were going to be two things, right? Where is it? Here. I told you there were going to be two things about radians, right? That is number one. Go ahead and write them down. Write it down as a note. Here comes the second one. Here comes the second one. If a number, if an angle is a multiple of pi, in other words, pi multiplied by something and or divided by something, like all of these in here, pi divided by 3, 5 times divided by 6, negative pi divided by 4, pi divided by 2. All of these, if the angle, again, if the angle is a multiple of pi, then that angle is called to be exact. All right, guys? Exact answer. That would be the exact answer. Why am I telling you this? Again, because sometimes books ask you to find the exact answer of something. The precise answer. Meaning we cannot round. All right? Meaning we cannot round. If after doing the multiplication, you have that, what was the first example? 60 degrees. If after doing all the exercise and the formula, you happen to have the 60 degrees is the same as, do a circle now. If 60 degrees is equal to pi over 3, and the book is asking you to find the exact, the precise answer, then you leave it like this, pi over 3. But this is, you forgot about the radians. I can write the radians, or I cannot write the radians. Why? Remember, no units means radians. So I can forget about this right now is in radians. This solution is in radians because it doesn't have any units. So it is radians. All right, guys? I told you at the beginning, two important things about radians that I did not write in the presentation, but I'm telling you right now, and you should write them, right? Number one, if the number doesn't have units, the number is in radians. Number two, if the question is asking you to find the exact answer, then you do not round. You leave it as a multiple of pi. What is a multiple of pi? Again, pi being multiplied or divided by something. That is a multiple of pi. All right? Beautiful. Let's continue with our presentation. And I have a little bit more examples, a little bit more exercises for you. Let's jump into this. Converting radians to degrees, all right? Now, how do we do this? Exactly the same. We are just going to use the other formula. Remember, there were two formulas, right? So we're going to use the other formula, and we are going to put pi over 6, the little number, pi over 6, instead of the rad. This is in radians, right? So we're going to put it instead of radians. Put this in the calculator, press enter, and get the answer. Look at this. Pi over 6, which is the radians, times 100 over pi, 100 over pi. We can even do this by hand. Look, pi and pi are going to get canceled. This is the beauty about this formula. Pi and pi are going to get canceled. So we have 180 divided by 6, which is 30 degrees. Huh? How beautiful is that? If you do this in the calculator, you will have the exact same answer. Let's continue. Let's see who gets number 2, B. Let's see who gets B first now. 3 pi over 2, change to degrees. Let's see it. Juan Sebastián Parrao, we have one answer, 270. Is that correct? Let's see. Sara Sofia, 270. Let's see about that. All right, so we have our equation now. 2 3 pi over 2, 3 pi over 2, and we multiply by 180 over pi, 180 over pi. This is just use of the formula. If we do this by hand, we will see that pi and pi will get canceled again. Huh? 3 times 180 divided by 2. This will be 270. Congratulations to Parrado. That person, Parrado, got it first. Nonetheless, congratulations also to Pardo, Sara Jimenez, Lunita, and Sara Galvis. You also got it correctly, guys. Let's continue with the C. I'm sorry, with the third one, C. Negative 3 pi over 4. Put it in the calculator, and the answer is negative 135, according to Sara Jimenez. Beautiful, Sara. You got it first. Amazing stuff. D now. 7 pi over 3 radians change to degrees. And the answer will be 420. Man. All right, 420. Now, if you happen to understand the mean behind 420, if you happen to understand the mean behind 420, and you don't want to be like the rest, you, instead of writing 420, you write 7 pi over 3 now. Let's see who gets it. Maybe some of you get it, right? All right, and last but not least, how much is 3 radians into degrees? 171.89. Beautiful, Richie. Perfect, my friend. Perfect stuff. All right. Again, guys, these use of formulas to change from radians to degrees and degrees to radians is absolutely simple. But we do have to remember or write down the formulas. We do have to have these by hand. All right, we do. So now that you have them, we can jump into the exercises. That was the class for today, the presentation for today. What I want you to do next is jump into these exercises. Look, work on the exercises. 43, let me finish the class here. Finish the recording here, and we will continue.